So in this section of our notes, we're going to be talking about quadratics written in a vertex form. And we're going to take a look at finding the vertex first in standard form, which is what we've been dealing with all of last unit. So in standard form, it's a graph written in ax squared plus bx plus c, where a cannot be 0. Okay? A little shortcut, the y-intercept, looking at a quadratic written in standard form, it's just 0, c. It's that back number. So if it ever asks, what's your y-intercept, and it's written in standard form, you just take a look. It's your back number. And you always write it as north here too. Again, the x value at any y-intercept 0, and then the y value is whatever that back number is. The equation for the axis of symmetry is x is equal to negative b over 2a. You're going to get those b and a values from your equation. Refresher on what the axis of symmetry is. Let's say you have a quadratic that's graphed, like so. The axis of symmetry is just that kind of line, usually graphed with a dotted line, that cuts that parabola right in half. So each point goes right through your vertex, and each point on the opposite side is the same distance. It's kind of like reflecting over that line. Cutting that parabola right in half. And it goes right through the vertex. That's your axis of symmetry. Because it goes right through the vertex, the x-coordinate of the vertex is just negative b over 2a. It's just your axis of symmetry. Whatever you get as your axis of symmetry, that's also going to be the x value of your vertex. You can use this value to find the y-coordinate by plugging that x value back in and then solving for y. Just plug in your calculator. The y value of your vertex. Questions over that? We'll see some examples here in this next section. Okay. So in these examples, we're going to use the formula x equals negative b over 2a to find the turning point of each of the following quadratics. So let's find that axis of symmetry. We abbreviate with AOS, axis of symmetry, using that formula. So first, before we do anything, label your A, your B, and your C. What's our A? Good. What's our B? 10. Very good. What's our C? Very good. So all you have to do once you identify your A, your B, and your C, you just plug it into that formula. What's the top going to look like if it's negative B? Negative 10, opposite of B. So this is a positive 10. When you plug it in, it's going to be negative 10. 2 times, what's our A? 1. So clean it up. 2 times 1 is 2. And negative 10 over 2 simplifies down to negative 5. So that's the equation for your axis of symmetry. Hence the word equation. So you must write it as x equals negative 5. It's not just negative 5. In the equation, there has to be an equal sign. You're going to say x is equal to negative 5. Right? To get your vertex, just like we said up here, whatever you get as your axis of symmetry, that's the x value of your vertex. Okay? What did we say we have to do with this negative 5 then to find the y value of your vertex? Well, it's not. That is the y-intercept. What do we have to do to find the y value? So kind of up in one of those. Well, we know our vertex is our x value of our vertex is negative b over 2a. Rodrigo, what do you have to do to find the y value? No, that's our y-intercept. What does it say right here? What do we do with the y value? Grace? Good. We have to plug that value back in. So we just take negative 5. Plug it back in. We do negative 5 squared plus 10 10 times -5 minus 27. You just plug it in your calculator exactly how it is written. And when we plug that into our calculator, what do we get? Negative what? Negative 52. I got it. Everyone else see negative 52? Got it? You should get negative 52. So that's the y value of your vertex. There's how you find your vertex when it's written in standard form. You find your axis of symmetry. Whatever you get as your axis of symmetry now becomes the x value of your vertex. You take that value, plug it back into your quadratic. Whatever you get is going to be the y value. Now, how do we find the y-intercept? That's just our what? Oh, you were saying this on the other one. Rodrigo? Yeah, it's just the c. What did we say our c was? Negative 27. Make sure you write it as an ordered pair. So we would write it as 0, negative 27. Questions over that? So when it's written in standard form, that's how you find these three key parts. Same thing with 2. Go ahead and label your A, your B, and your C. What is our A? 2. What's our B? And what's our C? We want to find the axis of symmetry, so again, use this little equation. What does it look like when we plug those values in? If it's negative B, what's going to go on the top? Oh, change the sign. If it's negative B, that sign flips the opposite to a positive 12. Times over 2 times R, what's our A? Clean it up. 2 times 2 is 4, and then 12 divided by 4 is 3. So again, that's your equation for your axis of symmetry. Don't just write 3. X equals 3. It's the equation, so there has to be an equal sign. Everyone clear on that step? Okay. To find the vertex, do we already know what our x value of our vertex is? The x value of our vertex. 3, very good. Just whatever your axis of symmetry is. What can we do with 3 to figure out the y value of our vertex? Plug it in. We take 3, plug it back into our original quadratic, plug your calculator. Exactly how it's written. What do we get when we do that? Megan? Negative 11. Everyone agree? Everyone get negative 11? Okay. Negative 11. So that's the y value of your vertex. There you go. And then the shortcut, what's our y-intercept? What is it? Yeah, 0, 7. It's always your C. So 7 is our C, so again write it as 0, 7, right, as an order pair. So 0, whatever your C is. Okay. Questions over that? Oh. We can find the vertex of a quadratic much easier when it's written in vertex form. So remember what we just did, we were dealing with standard form, which is ax squared plus bx plus c, where the leading coefficient a is not 0, because if it was, it cancels out the x squared, and then we wouldn't have a quadratic anymore. So again, that's standard form. What we're going to talk about now is vertex form. Okay? And it's written like this. The number sometimes, and then x minus h squared plus k. Again, this is called vertex form. It allows us to identify parts of a quadratic much easier, quicker. The turning point, which is also known as the vertex of a parabola, written in vertex form, is just h, k. Meaning, what do you know about the h in the equation? It's what? Positive or negative? Negative, right? H in the equation is negative. What do you notice about when we written as the turning point? It's what? Positive. So think an h is just representing a number. It can be 7 or 2 or 1 or whatever. So whatever number is in here with the parenthesis with the x, it's the x value of your turning point, but just with the opposite sign. Okay? What do you notice about the k? Is it positive or negative in your equation? And it stayed what? Positive. So whatever this back number you're either adding or subtracting, that's always the y value of your vertex, and that sign just stays however it is. So if it's negative, it stays negative. If it's a positive, it stays positive. How I like to think about it, whatever is representing your h is inside the parentheses. So when you take it out of the parentheses, it changes sign. K is already outside of those parentheses, so it just stays however, whatever it is. Right? So the only one that changes is that number paired with the x. The axis of symmetry, again, that's the line that divides the graph in half, creating a mirror image. It's found with the equation x equals h. It's no different. The x value of your vertex or turning point is always going to be that number for your axis of symmetry. X equals whatever your h is. Okay. Some other key things, if the number out in front, so a, this guy right here, is greater than 0, meaning it's positive. Someone knows the graph's going to open up or down. Okay? Up, yeah. Very good. If the number out in front is positive, it's going to open up. So if a graph opens upward, like so, is the turning point going to be a maximum or a minimum? This turning point is a high or low? So it's going to be a minimum. The turning point is going to be a minimum. So if the number out in front is less than 0, meaning it's negative, which way is it going to open? Down. Like so. Or something like this. That means, is the turning point going to be a maximum or minimum? Yeah, high up. Questions over there? I'm going to help us a little bit over there. Okay. Go ahead. Flip it over. We're going to use this quadratic to help fill in these answers and graphs. So just like we said on the front, this is written in vertex form. You know it's written in vertex form because it has the parentheses with the square. Our turning point. Again, just look at what's paired with the x. It's a positive 3. So when we write it as our turning point, what's going to happen to it? Very good. So we have a negative 3. The sign changes. Our y value of our vertex is this guy right here. Stays the same. So it's just going to be a negative 4. There's your turning point. Then really easy. Look at the equation. Are we going to have a maximum or a minimum? Take a look right out in front. Is there a minus sign right out in front? Nope. So it's going to open up or down if the front's positive. Up. So what did they say? If it's opening up, it looks like this. Is it a max or a min? Min. So if it's positive, there's no minus sign right out in front, it's going to be a min. And if you need to answer that question, wait till we're done graphing. And that kind of tells you if it's going to be a max or a min. The equation or the axis of symmetry. X equals what? Negative 3. Very good. Just the x value of your vertex. Whatever the x value of your vertex is, just x is equal to negative 3. What's our y-intercept? It's really tempting to say this. What do we think it is? Yeah, really tempting to say negative 4 because that was the shortcut on the last one. This time around, it's not just that back number. Okay? what do we say the x value is at every single y-intercept? What's the x value? 0. So what you have to do when it's written in vertex form to figure out the y-intercept, what are we plugging in for x? 0. To find the y-intercept when it's written in vertex form, you just take 0 and plug it in for x. So when we do that, what's 0 plus 3? And then what's 9 squared minus 4? 5. So our y-intercept is 0, 5. When it's written in vertex form, you just have to plug 0 in for x. You cannot use that shortcut of, oh, it's just the back number. That doesn't work because it's not written in standard form. You can write it in standard form and then look at the back number, but that's a lot more work. Okay, so that's all we're going to do by hand. The rest of it, we can use our calculator to graph it and then look at the graph to answer this question. So this is where you're going to need your graphing calculator. Have that out ready to go. I'm going to get mine out. And to graph it, go ahead, go to y equals, plug that quadratic in. So we're going to go to y equals, clear whatever's in there, x plus 3 squared minus 4. Go to y equals and plug it in. You're going to practice this, so when you come to your quiz and things like that, your test, you know how to use your calculator. I can't answer those questions for you on a test or book. We're going to look at the table first, because we can get our roots by just looking at the table. Okay, it's any x value that is paired with 0. So what are our x values that are paired with 0? It's one of them. -1. Okay. Do we see another x value paired with 0? No, when that happens, you might just need an arrow up or down. If you notice, our numbers are getting bigger, so I'm not going to arrow towards the positive. I'm going to arrow up towards the negative. Is there another x value paired with 0? -5. So that's another root. This guy paired with 0. That one's paired with 0. You can, if you look at your table and you don't have any x values paired with 0, you can use that 0 tool we talked about last unit, where you do second, trace, 2. You can do that as well, and it'll give you the same answer. Sometimes looking at your table saves you some time. So there's our x values. So to sketch a graph, you just plot the 3 key points, which is your turning point, your y-intercept, and your roots. So plot your turning point, which is -3, -4. Y-intercept 0, 5. And your roots are -1 and -5. And oh boy. And you just connect. Just a rough sketch. If you want more points, just look at your table and plot as many points as that will fit on your graph. We can just do the key points. That's fine. On the domain, if we look, it's slowly going to get wider and wider and wider and wider and wider. So they're going to eventually, very slowly, but eventually going to hit every single x value. Yeah. So does anyone remember what we say or call our domain when we hit every single x value? Yeah. You can write it in interval notation, which is -infinity to +infinity, or the whole same. All real numbers, yeah. Or all real numbers. double bar R. You might see that. You might see the words all real numbers. Just be aware. There's multiple ways to write it. Unless it specifies, I really don't care which way you use. Whichever one works for you. We do a lot with interval notation. Well, but it might specify interval notation, so it's good to know how to write it in that form. Here's the thing with the range. Is our graph touching every single y value? No. What's the last y value our graph touches? -4. Is it going up to all the numbers bigger than -4 or down to all the numbers smaller than -4? Bigger. So we can write it as y is greater than or equal to -4. That's one way you might see it. You might also see it as, written in interval notation, -4 is pointing on forever towards what? Infinity. That's also okay. Either one. You might see it both ways. I don't care. Whichever way you want to write it. I like y is greater than or equal to -4. You might see it as interval notation. So just be aware. There we go. Questions over that one? Do more. You get some practice on your own. Turning point. What's the turning point of this one? What's the x value of our turning point? 7. Very good. Sign switches. There's a -7 on the inside, so when we take it out, it turns positive. And very good. Sign does not change. That stays negative. Is this going to be a maximum or a minimum? Yeah, how do we know it's a minimum? Put negative out in front. So let them in. And it opens up. Again, if you're not sure, graph in your calculator. I'll tell you which way it's opening. Up or down. What's the equation for our axis of symmetry? Well, what's the number that deals with our axis of symmetry? Yeah, 7. It's just whatever the x value of your vertex is. So how do we have to write it? So x equals 7. Whatever, we know it's x equals your axis of symmetry. You just look at your vertex, take whatever your x value is of your vertex, x equals that number. So x equals 7. How do we have to find our y-intercept? Very good. You have to plug in 0 for x. It's not just a back number when it's written in vertex form. So what's 0 minus 7? And what's -7 squared minus 1? 48. How do we write it as? 0, 48. Right in the middle pair. Alright, we have that information. Let's use our calculator to find our roots. So again, you're going to go to y equals, plug in that function. X minus 7 plus 1 minus 1. Go to y equals, plug it in, get into your practicing. So if something's going haywire, we can get that fixed before you take your quiz. Then the second table, arrow through and find those x values that are paired with 0. Numbers are getting smaller, so I'm going to go this way. Do we know of any x values paired with 0? Good, 6 and 8. So those are our roots. This guy right here is paired with 0. This guy right there is paired with 0. So our roots are 6 and 8. So go ahead and plot our key points. We're going to plot our vertex, or turning point, 7, -1. Plot your roots, and plot your y-intercept. Here's the thing, is 0, 48 going to fit on that graph? No, so we need to plot it. Nope. What's going to happen? Just plot the vertex and the roots. And again, we didn't talk about the last one, but that axis of symmetry, and it is just solid line that goes right through your vertex. Solid line that goes right through that vertex. That's your axis symmetry. So cutting that parabola right in half. Okay. So what is the domain? And it's going to be the same for all quadratics. What's our domain? Yeah, negative infinity to positive infinity. Or you might see it as all real numbers. The range is what's going to be different. Think what's the last y value our graph touches? Negative 1. And is it all the y values bigger than negative 1 or smaller than negative 1?
Bigger than.
So how would we write it? Y is
Greater than or equal to.
very good. You might also see it written in interval notation. How would we write that in interval notation? Yeah, very good. Because it's pointing up to infinity. Questions over that? Okay, one more. You sign and practice. So what's the turning point for 3? Very good, 3, 9. Or 2, 9, yeah. So negative 2, so the sign switches. It's on the outside, so that 9 stays the same. Is there a negative right out in front? Yeah, so is it a maximum or a minimum? Maximum. Whenever it's negative, it's a maximum because it means it's opening down. Again, if you're not sure, wrap with your calculator. It'll tell you. What's the equation for our axis of symmetry? Good. X is equal to the x value of your vertex. What do we plug in for x to find the y-intercept? Good. Go ahead and do that. And make sure it's really important. Don't forget that minus sign out in front. I did first period and it was a mess. Don't do it. Remember it. Give yourself a headache if you don't. So when we simplify this down, 0 minus 2 is what? Negative 2. Break it down a little bit more. You can point in your calculator exactly how it's written too, right off the bat. That's totally fine. Just be careful you're plugging everything in correctly. What do we get when we do negative 2 squared? 4, but you have to remember that minus sign is still out in front. So that drops down with the 4. So what's negative 4 plus 9? 5. So our y-intercept is 5. So how do we write it?
Oh, 0.
Very good. 0, 5. Okay. To get the roots, we can use our calculator. Have your calculator. Go to y equals. We have a negative. But minus 4. Minus 2. What is that thinking for? Squared plus 9. So let's plug that in y equals. Where do we go to get the table? What do we press? Second graph. And find those x values that are paired with 0. What x values do we have that are paired with 0? Negative 1 and 5. Right here. You might have to arrow up and down to find them. They might not always pop up on your screen. So go ahead. Plot those 3 key points. Your turning point, 2, 9. Your y-intercept 0, 5, and your roots negative 1, 5. Looks something like this. Make sure it's nice and curved, not so much a point. And again, that axis of symmetry is just that dotted line that goes right down the middle of that, right through the vertex. What's the domain? What do we say the domain is always going to be? Negative infinity to infinity, or all real numbers, whichever one works for you. The range. Again, ask yourself, what's the last y value this graph touches? 9. Is it pointing to all the numbers bigger than 9 or smaller than 9? Smaller. So you would write this as y is less than or equal to. Or how do we write this in interval notation? Be careful. Perfect. Tricky. It's really tempting to say 9 to negative infinity because how the graph is looking, but remember, I always have to go from small to big. So negative infinity is smaller than 9. So negative infinity has to go first. Okay? Is anyone noticing kind of a shortcut with the range? What was the last y value our graph touched in the range on this one? 9. What's the y value of your turning point? 9. What was the y value in our range? What's the y value of our turning point? Negative 1. You really don't even have to be able to graph it to figure out your range. It's nice to get a good visual, but that number is going to be the y value of your turning point. That's a good way of checking. Make sure you have it right. These numbers should match. And then if it opens up, it's going to be bigger than or equal to that number. If it opens down, it's going to be less than or equal to that number. So you can know your range without even looking at a graph or quadratic. Questions?